So in this video, we'll take a brief look at Studio 5000. So let me open the software. And it's asking what I would like to do at this point. So I think I would like to create a new project. And it's asking for what controller would I like to create the project. So let's go with a L18 ERM, and I'll give the project a name. This will be Project 100. Now I know the controller has revision 30 on the firmware, so I'm going to leave that as 30. I know there are no expansion modules, so I'll select 0. This is very important. If I make a wrong selection on the expansion modules, when I try to download, it will fault. And then I have to clear the fault before I can do anything else. So I need to be sure how many expansion modules I have connected. So the factory PLC has 0 modules. So let's go with that for now. We don't want security on the controller. It sort of gets in the way and creates problems if we forget passwords. So we'll leave that as no protection. You might have to wait for a little bit for it to start up. It's a fairly large program. And I'll try to make it fit the screen here. Okay. Okay, let's make it fit there. Okay. So on the left side, this is the controller organizer. It shows everything. The logical organizer shows just the ladder logic. So for now, we could work off of this screen, but let's go back to the other one. It has more information. Let me explain some of what we're seeing here. This is the name of the project. This is the list of controller tags. So a tag is like a variable name. It's like a nickname. So if I double click on that, I can see right now the only tag names I have relate to the physical I/O on the controller. Inputs, this is an I, these are inputs. This is an O, which is an output. The C is the configuration data. And it lets me configure how the inputs operate. But let's leave that alone for now. We don't want to change too much. The rule of thumb is don't make too many changes unless you're really sure that you want to. The default setup works great. So let's look at the tasks. The default setup is to have a main task that is continuous with a main program and a main routine. So this is fine for what we're going to do. Down here at the bottom, we can see that I have embedded I/O and I have no expansion modules, and this is correct. It also shows that I have an Ethernet port, which is also correct. So this is just I/O information that I'll leave that alone. So let's go to the main routine. Here I've got some blank ladder logic. It's ready to go. What I'll do is I'll create a very simple program that has one input and one output. So here's an open contact, and here's a coil. So if you hover over almost anything on this program, it will tell you what you're looking at. So this is an examine on contact. What this means is that if the input itself turns on, this will conduct electricity. If it was a relay, this is software, so what it does is it becomes true. So if this is true, the output will turn on. So I use the examine on because I have a normally open push button connected to that input. So I'm looking at the controller and I see input 0 has a push button attached to it. And I see output 0 is a green lamp. So let's use those connections for this project. What I'll do is I'll right click and create a new tag. So the tag name will be start push button. It's going to be an alias tag because it comes from the external connections. If it's an internal tag, a base tag, it exists only inside the processor. So the rule is if I have a physical connection, I need to make an alias tag. It will ask an alias for what? You'll say local input data bit number 0. So the proper name is local 1 input data 0. The scope of this tag is I would like for it to be at the project level, which is the highest level. That way it's available across any program I might create. So let's do that. Also, make sure that you have read-write access. Just in case we will do something like a messaging instruction later, we don't want to have to go back and make a lot of changes. So let's create that tag. Notice here it has the name of the tag and also the alias location. You can turn that off, but then it becomes a little confusing. You can't tell which are alias tags and which are base tags. So I like to leave that on. You can find that under Tools and Options, Ladder Editor Display, right here. So if I turn that off, you'll see that it goes away. And it's not really clear what that is. If you hover, you can see it pops up. But I just like to see it, so let's turn it back on. Okay, so let's finish the coil. Right-click, New, green lamp. It's an alias for local output data 0. Notice that this turned blue. Blue means that it's okay. If it's red, something's wrong. So let's break it again. Let's put a examine on contact in here and not label it. Now it's broken again. So I don't like that, so I'm going to get rid of it. So this should work. If I click on this verify button, it will check it. I didn't get an error message, so it should work. It may not work the way you want it to, but it's nothing. There are no major problems with it. So the program won't tell you if your program is actually going to work correctly, but it'll say that it's at least not really broken. So this looks good. Let's download this to the controller so we can try it out. So if you click on Who Active and click on a driver, and wait. It's important that we be patient here because the software is looking at the network. We have the animation. it's checking to see who's available. So we're going to go to 102, and I wait. I can download it to 102. It's asking, are you sure you want to do this? I say yes. Here it goes. Go back to remote run mode, yes. Now I'm online. I see these green bars here. I see that it's in run mode as well. And I see that I'm in remote run. There is a switch on the front of the controller behind a little door. If I flip that switch to run, notice that it's now in run mode and I can't download to it anymore. So the only way to switch it out of run mode is to either switch that switch back to remote or switch it to program. If I go to program mode, the controller is not running anymore. So it's going to depend on what you're doing. For example, if you have a large process or machine that's running, I probably don't want to go to program mode because it turns everything off. If that's okay, then that's fine, but it shuts everything down. So the safest position to be in is the remote position. So in remote, I can click and go back to run, and I can also download programs to it, and I can also make changes on the fly. So it's probably the best setting if you're making changes. If you want to lock out changes, go to run mode on the switch, and people can't make changes. So let's try it out. I'm going to hit the green button. The push button turns green, so it's true. It is on. The green lamp is lit up. It is on as well. So if I let go of the push button, it goes off again. So there we have it, a successful first program. Let's make a change to it. We always have to change things. So I noticed that I have a stop switch connected to input 1. And it is a normally closed push button. So let's add a start-stop control circuit with a seal in so that I press start and it stays on. What I'll do is I'll double click and go into edit mode. So what I'm doing is I'm going to edit this rung. I note this one is still running, so it is actually still running. The program's still working, but I'm going to make changes to it and then push those changes down to the controller on the fly. So this is the way you want to make changes if you know what you're doing, because an online change becomes live as soon as you accept those changes. So if you're not really sure, you might not want to do online changes. You may cause problems. You may break something or hurt somebody. So you just need to be careful and know what you're doing. So let's add a stop push button. Right click because it's new. Stop push button. It's an alias for input number 1. And notice how input 0 is grayed out. It's already been used somewhere, so it's handy. It tells me what's unused. So 1. So now I have stop and I have start. When I press stop, it's live, but it's not really fully live yet because I haven't accepted the changes. So let's go ahead and add a branch around the start push button. So a branch is a path around a component. I would like to put the green lamp in that branch. So I'll pull down the name green lamp, not the alias name, but the name itself. So now I have a stop button, a start button, a lamp and a seal in around the start push button. So let's accept those changes. And it says, are you sure you want to do this? Yes. So what I have now is a start seal in circuit. If I press stop, it turns off, start, stop. It works fine. Now I have a normally closed stop push button. So you might be wondering, why don't I use the closed symbol here? It's because the push button is already on, so I have to use the examine on contact. Well, let's change it and see what happens. So double click. I can double click on the symbol, change it to the off type. So it looks like it might work. It's a closed switch, right? So accept those changes, press start, and nothing happens. Because the stop button is already on, and this is the off symbol. So if I press the stop and hold it, now it works, but that's not the way it's supposed to work. So let's fix it. Let's go back to the way it was. So double click, and accept. Start, stop. So there we go. It's actually very simple. It's very repetitive. Once you have done one or two lines of instructions, you'll see what I mean. So let's add something to it. This is the new rung instruction. Let's use one of these old tags instead of creating a new tag. So let's pull down an open contact. Let's bring down the push button name. Let's create a coil that doesn't go anywhere. It's not an external connection. So let's do a right click and make a new tag. We'll call this temp, and it's a base tag. So that's just an internal tag. Let's accept those changes. And you can see temp turns on, but it doesn't do anything outside the program. So let's create another line that uses something that we've already created, like green lamp. So it's not a new tag, so if I left click here, double left click, I can select from available tags that I've already created. So let's use green lamp as an input, and let's go to a coil called right click, new tag, green lamp works. And let's accept those changes. So now if the green lamp is on, green lamp works is also on. If I press the start button, temp is on because it shows that this start button is on. So I'm just adding more functionality to the program. It's actually fairly simple. Once you get past the mechanics of pulling down contacts and coils, it becomes a question of where are the instructions? How can I find what I need? So for example, let's add a timer that times for 10 seconds after the green lamp turns on. So let's put it right here, right in between these. We'll do a new coil, a new rung. We'll pull down an on timer, and we'll pull down a contact. Notice the favorites tab. The favorites tab gives you quick access to the things you do most often. So let's pull down a contact, and let's bring the green lamp down. So I'm going to have a timer that runs for 10 seconds and then turns on. So I'll right click, new tag. This is going to be time relay 1. It's always a base tag. My preset time is in milliseconds, so 10,000 milliseconds is 10 seconds. And let's while we're here, let's connect this to a a coil called times up. The way I'll do that is bring down a branch, and I'll bring down a contact, and it's out of TR1, so I'm going to type TR1 dot. TR1 has several bits that I can work with. The done bit is the one I want. When the timer's done, this turns on. So let's put a coil after the done bit, and it's called, right-click, new tag, times up. Okay? And let's accept those changes. So let's make the green light turn on. The timer is running. 4, 5, 6, 7, 8, 9, 10 seconds. Time's up. Notice the timer stops at 10 seconds. It's done, so time's up. If I press the stop button, my timer clears out to 0. There is a retentive timer that doesn't clear out to 0. So whatever you need, you can probably find it on these tabs up here, or you can make almost anything work. Let's, just for fun, since we're here, let's add a compare function, just because. Now, I would like to know when the time delay has gone longer than 3 seconds. That's a greater than. So let's click here, add a new line. I'll pull down a greater than instruction, and I'll pull down a coil as well. So source A is going to be the accumulator out of TR1. So I'll type TR1 dot ACC. Source B, 3 seconds is 3,000 milliseconds. So if this is more than 3 seconds, this will turn on. So right click, new tag, over 3,000. And accept those changes. So let's run it. Turns on, over 3,000. And time's up. So whatever you need, you can probably make it work. The way to be successful in this environment is to put it on paper first, come up with a rough plan of what you want, and then be sure of what you want. The worst thing is to make changes after the fact because it's misunderstanding or maybe your goals change. It just takes time to do that. But be clear on what your program should do at first, and then just make the basic functionality work correctly and add things to it. So let's wrap this video up, and then we'll do some other ones with other projects in mind.